Today we're going to look at Bayes' theorem. We'll look at the formula for Bayes' theorem, and then we'll actually look at an application or a word problem using Bayes' theorem. Bayes' theorem is really just a conditional probability, but it's a little bit different. Most of the conditional probabilities that we've done thus far would be something to the extent of what's the probability that A has occurred given that E has occurred. So E happens and then that somehow affects the probability of A. Bayes' theorem is just the reverse of that. Bayes' theorem is saying, okay, well, let's say I know that A has occurred. What's the probability that E had occurred before A? The formula basically is this. We're going to take the probability of E times the probability of A given E, and then we're going to divide that by the probability of A. Now that may not make a lot of sense now, but hopefully after we do this example it'll make a little bit more sense. So suppose that your company classifies its customer into three categories: silver, gold, and platinum. Now 55% of them are silver, 10% of them are platinum. I wonder what percentage of them are gold then. Customers in silver category allow their accounts to go overdue 10% of the time, gold 5% of the time, and platinum 2% of the time. Find the probability that a customer is gold given that they are not overdue. Now, this problem is pretty straightforward, but I think it would probably be a good idea if we follow some steps. Step number one is to draw a tree diagram. I'm going to try to do that based on that information on the last slide. So see how that goes here. We know that we have three categories of customers. We have silver customers, we have gold customers, and then we have platinum customers. We also know that 55% are silver. We know that platinum is 10%, and as you'll notice I'm not writing these as percentages here, I'm writing them as decimals. That's going to save me a little bit of work later on. And then let's see here, 55% are silver, 10% are platinum. That totals up to 65%. That would make 35% of them to be gold, because all three of these have to add up to 100% of our customers. I think that works out okay, doesn't it? Yeah, that looks good, because that would be 65, so good. Now let's look at the second stage. So we have silver, gold, and platinum. But then for each of these categories we can have overdue customers, and then we could have customers that are not overdue. We could have overdue customers and not overdue customers in the gold category, and finally we could have overdue customers and not overdue customers in the platinum category. Now I believe it's stated that there was 10% in the overdue category for silver, so I'm going to write that as a 0.1. And then for the not overdue, that would have to be the complement of 0.1, which would be 10, or 9.9. Decimal's not working there. And then for the gold it was 5%, so that's going to be 0.05, which would make 95% not overdue. And then for the platinum it was 2% overdue, so then that would imply 98% are not overdue. So there's our tree diagram. Now, based on our formula in our tree diagram, we can start pulling things together. Before we do that, let's go back and analyze a little bit of what our question is. I'm going to jump back here a couple of slides. The question is to find the probability that a customer is a gold member given that they are not overdue. So what I'm going to do here is I'm going to go ahead and write down what my question is asking here, and it is simply stating the following. It's saying find the probability that they are a gold member given that they are not overdue. So to get the answer for that, we're going to have to find the probability of gold times the probability of not overdue given that they're gold. And then we have to divide that by all the ways to have not overdue. Okay? So this is based on the definition. The probability of gold given that they're not overdue, based on Bayes' theorem, is the probability of gold times the probability of not gold given, or not overdue given gold, divided by the probability of not gold. Now let's go back to our tree diagram and see if we can dig some of this out. On this particular tree diagram, we've got all the information that we need for gold and not overdue. That would be this highlighted region right here. In other words, if I wanted to find the probability of gold and not overdue, I'm going to take 0.35 times 0.95. That's going to end up being our numerator. Okay, so this is the probability of gold, 0.35. And then the probability of gold or not overdue given that it's gold is going to be 0.95. The other piece of this is going to be the denominator, which is going to be all the ways to not be overdue. Well, we have a whole bunch of those ways here. So to find the total probability of not overdue, we would have to take 0.55 times 0.9, 0.53 times 0.95, 0.10 plus 0.98. So that's three things that we would actually have to do there. So let's just go ahead and write this out right here on the slide. Change my pen here again. So the probability of gold, actually let's do that right here, and not overdue, is going to be 0.35 times 0.95. The probability of silver and not overdue is 0.55 and 0.9. And then the probability of not overdue with it being platinum is going to be 0.1 and times 0.98. So these are the decimals that we're going to have to use in our formula. These are the multiplications. So then let's go ahead and substitute that into our formula here. So the numerator is going to be the probability of gold, which again was 35%, times the probability of not overdue given that was gold, which was 0.95. And then the denominator is going to have to be all the ways of getting not overdue, which is going to be 0.55 times 0.9 plus, I'm just writing down those multiplications that we had on the last slide. And then finally the platinum ones, which was 10%, and 98% of those guys are not overdue. Alright, so step 2 was to isolate and substitute into the formula. We isolated the decimals that we needed so that we could substitute them into the formula. Next step is to obviously then work this out, calculate it. So that's step 3, is to calculate the value. We're going to use some technology here. I would anticipate that you would do the same. Now I'm going to use something a little bit different here since I'm using the computer. Basically what I'm going to do is I'm going to carefully type in the values that we're going to need here in our numerator. I believe for the gold there was 35% gold and there was 95% of them overdue, and then I need to divide that by, there was 55 silver times 90% overdue, or not overdue. 35% times 95% not overdue, plus 10% times 98% overdue. Now it's very important that we put parentheses here and here, and here and here. If we don't put the parentheses at the beginning of these expressions, then what it's going to do is it's going to take 35% times 95%, and then it's going to divide that answer by 0.35. And then times that by 9, and plus this, which is not what we want to do. And you on this calculator, it's kind of nice, because as soon as I hit enter up here, you're going to see that this comes out exactly the way I had written it on the PowerPoint. The nice thing here is this gives us our answer both as a decimal approximation and a fraction output. I tend to prefer the fraction output because it's exact, although the decimal output is extremely accurate. So let's jump back into our PowerPoint, and it looks like we've calculated our answer here, and the answer could be written one of two ways. We could say our answer is 665 over 1851, or we could say 35.93%, and that's approximately the correct answer there. So now we've got our answers, or at least we think we do. So what would step 4 be? Well, step 4 is to check our answer and see if we've answered the question that was being asked. And let's see if that makes sense. Let's go all the way back to the very beginning here. It says, so we've got these customers, 3 categories, and probabilities, and we want to find the probability that a customer is a gold member given that they are not overdue. Well, if we go to this tree diagram, we can see that the majority of people are silver, and they have about 90% of those are overdue, or not overdue. So you would expect this to have the highest percentage, and then this would have the lowest percentage overall. In other words, you would expect the probability of them being silver, given that they're overdue, to be the highest percentage, and indeed it would be. Gold would be somewhere in the middle, and then platinum would be the lowest of the bunch. So you would expect this to be the biggest, and this somewhere in the middle, and this to be the least. So I think that our answer here of 35.49% is pretty reasonable, and I'm going to stick with that. The probability of them being gold, given that they are not overdue, is approximately 35.93%. And that's a nice example of Bayes' theorem.